Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Dear students, welcome back to this TV learning series program. Teacher Patrick will be with you again, once again, and I'm very excited to meet you again. Still, I'll be with senior ethics students. We'll be talking about Unit 4 and 5. In the previous lesson, we had to do some questions as a continuous assessment, and we're still looking at the questions as well. This is the lesson 7, and in the previous lesson 6, we are looking at the same questions, but I said you will not be able to understand the concepts unless you are faced with some questions, or you'll not be able to know how much you have retained unless you'll be able to answer the questions or be able to meet some questions, different questions, not only 1 or 2 or 3, but different questions will help you to understand whether what you have learned has been, you have retained the content. So we're still going to continue answering some of these questions, and then as we go along, because the Unit 5 is not complete, but I said in the previous lesson, I thought it necessary to first go through and answer some questions, as we will be answering them together, not me alone. So I need your help. Please be ready with your pens and notebooks so that you can write some information. Compare what you think is correct with what I'll be writing on the blackboard. Question number 4, remember this is number 4, because I said it is continuous. So I'm not starting with question 1. So one would wonder, now why are we starting with question number 4? I said it is a continuation of the previous lesson. So we had answered some other questions. So let's continue. So 3 reactions of methyl benzene can be summarized on a flow sheet. Name the substances A and the reagents B and C. So this is the methyl benzene. Methyl benzene is commonly coming back because we had finished this in in the previous lessons. So that's why the questions on methyl benzene are commonly coming back. So draw the structural formula of 4-methyl. Before we go to that one, we first look at name the substances. This is substance A, and then the reagents B and C. This is B and C, and then B, draw the structural formula of 4-methyl benzene sulfonic acid. So the 4-methyl benzene sulfonic acid is over there, so you can be able to answer those questions together. I hope you are writing even the answers before me. So I would actually ask you to always compare your answers with mine. So let's go straight to question number A, part A of number 4. Still, I said we'll look at it is the continuation of the solutions that we are looking at. Now, part A, you look at A where A is, so we need to give the name of this compound. So when you look at that one, we have the methyl group, and then we have the bromine. So in this case, if we have the methyl group, it means that methyl group attaches a special name to this benzene, which is taurine. So this is either, it will be so it will be 4-bromotaurine. 4-bromotaurine, or we can name it, that is the common name, or we can say it is 4-bromomethyl benzene. 4-bromomethyl benzene. So both names are accepted. the common name, and even the IUPAC name. So this is the IUPAC, and that is IUPAC name, and that is the common name, taurine, 4-bromotaurine. That is A. Reagents. Methylbenzene reacts with B and C to form the changes over here. So we only need to look at that change, because this remains as this. So we just look at the change. So what brings this change? So we need those reagents, B and C. B and C, B and C. So the B either can be concentrated nitric acid, because that is a nitration. And we can also have concentrated sulfuric acid. So those are some of the reagents used for nitric acid. The nitric acid is always not nitrous acid. So that is the reagents B and C that is for step 1. Draw the structural formula for 4-methylbenzene sulfonic acid. 4-methylbenzene sulfonic acid. That is part B of Roman 1. 4-methylbenzene, so that is methylbenzene sulfonic, the methylbenzene sulfonic acid. So that means the methyl group is attached on the carbon number 4 of the sulfonic acid. You have two substituents. You have a methyl group, but that methyl group is attached on carbon number 4 of the sulfonic acid of the benzene ring. So if we were to draw the structure, this is how the structure looks like. Remember the delocalized electrons within the ring. So it means the numbering now starts from here. This is a sulfonic group. So the numbering starts from here. That is why the methyl group comes on that position. So the methyl group is now becoming another substituent. And whenever we have a sulfonic acid and the alkyl group, the priority order, sulfonic acid comes first in the priority order in regard to the alkyl group. So that is why we have the methyl group on carbon number 4. So let's continue and say Roman 2 says state the formula of the molecule which attacks the benzene ring in reaction 3. This is the reaction 3. So what is the formula? So here, either we have, that is Roman number 2, the formula, this is sulfur trioxide. That can be the sulfur trioxide that can be used. Or you can have either hydrogen, because there are different ways. You can have a sulfur trioxide, or maybe we can even leave that one alone. We just leave the sulfur trioxide. Or the sulfur trioxide can also is the one that is used as one that will be attacking the benzene ring. And then name the reagent, that is name one important group of industrial product that is made from benzene sulfonic acid. That is Roman number 3. What do we make in benzene sulfonic acid? What do we get from there? So the main substances that we get from this compound are detergents. And there are so many detergents, especially these powder form detergents. Either you have, these are common names. You have Omo. I don't know whether Omo is double M or what. I'm not sure about this. We have Omo, you have Nome, you have so many other. They come in different names and within different colors for their attraction. So those detergents are made from this compound, benzene sulfonic acid. Part C, write equation to show how the catalyst, iron 3 bromide, induces polarization of bromine molecules in reaction 2. We have reaction 2, but the bromine, this should be reaction 2, because that is where we find the bromine being attached on this. And that is where the bromine is being added. So that means we are supposed to show how the iron 3 bromide induces the polarization of the bromine. So this is what happens. So you have, this is part C, Roman 1. So you have bromine molecules. Bromine molecules they have got the lone pairs, very different lone pairs. So that means this, when it reacts with iron 3 bromide, the iron 3 bromide, remember, has the empty orbital. So it will pull the lone pairs. We will accept the lone pairs. And as it pulls out the lone, this bromine uses the lone pairs and is pulled by this iron 3 bromide. So this bond will try to weaken out. And then what will happen, you'll get bromide with a positive charge because this bond weakens. And then as it weakens, the bond breaks out, and then this bromine is accepted by that iron 3 bromide, and then it forms this complex compound of the iron bromide. So that is how the polarization takes place, by pulling the bonding electrons. Classify reactions as fully as possible. So these reactions that are taking place, how do we classify them as fully as possible? So we have, that is Roman number 2. Reaction number 1, that is step number 1. This one is going to this. So probably that one we can call it either nitration, because we see the nitronium ion is substituted on the benzene. So that is for part 1, or reaction number 1. And reaction 2, the reaction 2 we have said is where we have, because we have only 3. So this is 2, where we have the bromine added to this in the presence of iron 3 bromide. And then probably we can call it bromination. And then 3, we can call it sulfonation. And call it sulfonation. So all these are categorized as electrophilic substitution reactions. Electrophilic substitution reactions. So all these reactions all together. So let's move on to another reaction. Number 5. 3 hydrocarbons, A, B, C, with formula C9H12, were oxidized by hot potassium permanganate. Hydrocarbon A gave benzoic acid. This is benzoic acid. Hydrocarbon B gave benzene 1,2-dioic acid, which is this one over here. And then hydrocarbon C gave benzene 1,2,3-trioic acid, which is over here. Then we are asked to suggest the structures of A, B, and C. So how do we come up with those structures? So first of all, you have to look at the compound that is this hydrocarbon, C9H12. That is number 5. So you look at C9H12. Is this a hydrocarbon? Is it an alkane? No, it can't be an alkane. If it was an alkane, then that means you remember the general formula for the alkane, 2n+2. So if it was an alkane, if the hydrocarbons are 9, then we would have how many hydrogen atoms? There will be Now the hydrogen atoms would be 20. So that means this is not an alkane. Is it an alkene? Because it is a hydrocarbon. Hydrocarbons, you remember, there are three classes. We have alkanes, we have alkenes, and we have alkynes. So is it an alkene? Remember the formula for the alkenes? CnH2n. So if the carbon atoms are 9 over here, then we'd expect the hydrogens to be 2 times, which is 18. But these ones are 12. So it is not an alkene. So is it, so we said this is for the alkanes, this is for alkenes, and then you have to look at the alkynes, CnH2n minus 2. That is the general formula. So we're trying to come up with the structure of this compound. So if the carbon atoms are 9 over here, so that will be 18 minus 2, that is 16. That is, so it is not an alkyne. So it doesn't belong to any one of these three, and yet it is a hydrocarbon. So what do you do? Think of the benzene. So think of the ring that comes in. So that is why you have to think of the ring, which is benzene. So which compound is likely to be this? So you need to look at, we don't need this one. So if it is benzene, CH2, CH3, this is the one we've come up with. So you look at this compound. How many carbon atoms does it have? We said this one has 9 and this one has 12. So that means 9 carbon atoms. Are these, on each corner, remember, they are carbon atoms. So how many are they? You have 1, 2, 3, 1, 2, 3, 4, 5, 6. Are they, how many are they? 1, 2, 3. You have 1 here. You have 2, 3, 4, 5, 6. How many are those? Then 7, 8. So the number of carbon atoms are not yet 9. Remember, we need 9 carbon atoms. So what do we do? And remember, the hydrogen atoms have to be 12. So that means we need another carbon atom. So another carbon atom is required. So it will be CH2, CH3. So how many are these? So we said these are 6 carbon atoms, 7, 8, 9. So the number of carbon atoms now are 9. Now we need to look at the hydrogen atoms. How many are they? So here on each corner, you remember there are hydrogen atoms here for the benzene. And then how many are they? 1, 2, 3, 4, 5. So you remember we need 6. This one here, we don't have the hydrogen atom because that hydrogen atom has been substituted. So we have 1, 2, 3, 4, 5. When we add this, this is 8. When we add, this is 10. This is 12. So that is the number. That is how you come up with this structure. So this is the compound. This is the compound that was able to be oxidized. So if this is an alkyl halide, so this is an alkyl group. So when this compound is oxidized with potassium permanganate or with any other oxidizing agent, so this one is the one that will move. So you have potassium permanganate. This reaction takes place in presence of acid and heat. So we are able to get potassium benzene, benzoic acid. So that will be the benzoic acid. That means this one is oxidized to get this. So what does, if we had, for example, now this was oxidized, another compound B was oxidized and then gave 1,2-dioic acid, so it gave this one. That means that this substituent, this is the substituent that is being oxidized, right? So if this is the one that is oxidized, then that means that we had two substituents. So this is A, this is compound A that gave this compound here, over here. Then compound B, it means the substituent that we have over here, this one here, was occupying this position that we have here for the benzene 1,2-dioic acid, and this over here. So you have two substituents for this compound. So B will look like this. Check whether you have the same compound like mine. So this is how the compound looks like. Two substituents. Look at this one here. We said from this, we had this one over here. Now from this one here, the second compound B, we have two groups of carboxylic acid. So that means two substituents have been oxidized fully. So in presence of the potassium permanganate, this is the common oxidizing agent, strong oxidizing agent, so potassium dichromate, I beg your pardon. And then that will produce the compound. This is heated. So we said this one produces our compound that we have over there with two carboxylic acids occupying two positions. So it becomes obvious when you come to this compound over here. So that means the alkyl groups, those two alkyl groups that we have mentioned here, are occupying three positions of the benzene ring. So if we have compound C, so remember compound A is this is compound B, and then now we are going to look at the compound C. I hope you have got the answer already. So this looks like this. Three positions. You have this one, CH2, CH2, CH3. Then you have CH2, CH2, CH3. So there are three positions that you have. Position number 1, 2, 3. So this one will also be CH2, CH2, CH3. All these compounds, now this one will produce the one that we have over here. This benzene 1,2,3-trioic acid, because these are the substituents that are getting oxidized. So that gives us the compound that is given over there, ACH2COOH, and giving those three carboxylic acids. Do you have the same answers that we are coming up with? So let's continue. Look at another question. The scheme below shows some reactions starting with methyl benzene. I said methyl benzene. We have already finished this methyl benzene. So the reactions of methyl benzene will be common in our questions now, because I said this is a continuous assessment. We are assessing ourselves to see how much have we retained. As I said earlier, you need to assess yourself. And how do you assess yourself? Looking at the questions. If you are able to answer the questions, then you are assessing yourself. That is the only way that we can be able to, that you can use to assess yourself. This is methyl benzene over here. And then give question number 1. Give the reagents and conditions used to carry out reactions in steps below. Step number 1, 2, and 3. So those are steps. We have step number 1, we have step number 2, now we have step number 3, then there is another step number 4. But we are asked all these, give the reagents. Step number 1, where we are moving, methyl benzene in step 1 is now changing to chloromethyl benzene. Chloromethyl benzene. So what is happening over there? So now, the answers, as I said, always compare. So I'll just give some few minutes. I hesitate a little bit so that you can write the answer first. And then compare your answer with mine. That is the only way that we can be able to look at these questions. Now, Methylbenzene is changing to chloromethylbenzene. Chloromethylbenzene. So what is happening over there? The reagents for part A, reagents in step 1. We have step 1, we have step 2, and then we have step 3. We need to state the reagents. Step 1, that is chlorine. Step number 2, we have, that is sodium hydroxide, aqueous, because that is a nucleophilic substitution. You see there, only the OH is substituting the chlorine over there. So that is sodium hydroxide, aqueous. Step number 3, we are moving from here to here. So this question is continuously coming back. So this is either concentrated nitric acid and concentrated sulfuric acid. Those are the reagents that we are using over there. Part B, what type of reaction is involved in step 4? Step 4 is part B. In step 4, you can be able to look at that. I think we've not been able to look at this because this is a reduction reaction. So this is reduction reaction. We had, I think, answered the same question, similar question, in the previous exercise. So I would expect you to have the answer already. Give the structural formula and the name of compounds A and B. The structural formula, that is C, compound A, I think you can be able to look at the compound A, where it is. So you have the methyl group. So you have either this, or you may have this compound, CH3 with chlorine. So these are isomeric compound molecules. What is the name of the mechanism involved in step 1? Step 1. This is free radical substitution reaction or mechanism, because we are talking about the mechanism, right? And then step number 2, where is step number 2? This is over here. I said that is nucleophilic substitution. Nucleophilic substitution mechanism. I hope you've been following. I hope you've been able to compare your answers with mine. And as we go along in the next coming series of the lessons, you should be able to answer some of these questions. Look for other questions. E-learning platform for REB, find there some books, and even some questions. Thank you so much for being with me in these 30 minutes. I hope to see you in the next lesson. Bye-bye.